Hello, welcome back. Last time I checked in with a devlog, we talked about finishing up some draw mode stuff, and we're on to the next problem now. And that was mostly about maps and ink modes. It's a pain, we're losing frame rate from the capture. So what are we looking at here? On the surface it looks like just a regular image. We can move the image around, stuff like that. Big deal. Hover over the top of it and it gives us some malarkey about some coordinates and some polygons. What do you mean polygons? Why is there 28,000 polygons for this thing? Well, that's because this is not actually an image, this is a map. And what we're testing here is a way of doing clipping to reduce the amount of work, so we can throw a map into a scene and have it condensed down to polygons, just so we can do this one, rotate it, or more importantly, have the camera rotate that we are looking at this thing through. That's the real goal of this stuff. So up the top you'll notice there's two values. Our map is 28,000 polygons, and our clipping version here is reduced that down to 12,000. Now, the map, we're calling it here, it's like a simulated map, just a thing called map array, and every cell in that array I'm treating as a tile, and that tile has been rendered as a filled quad. So inside each zone, this is 546 polygons. And the way it works is that, well, I've tried this before a few different ways and got, varying degrees of success, I think. And this one seems to be the best approach so far. Obviously, if the whole thing's in view, you've got to do the whole thing. There's no reduction there. And in this case here, you're not going to have situations where you've got the whole map rendering. Well, I wouldn't have thought so anyway. You can move around too, by the way, the camera can move. So if we look closely at what's going on, I'll zoom in a little bit. I'll come down a bit. So our clipper, there's two basic passes that I'm using here. I'm running through and I'm working out which portion of the map is going to be inside the viewport, the camera, or the screen, you might think of it as. If you do that normally and there's no rotation, like here for example, that's fine. You end up with a very small amount of lists of polygons on the edges of these of the map that are very close to the edges of the screen. So that's what we want to do. We want to try and make sure we're not rotating and scaling vertices we don't need, and more importantly, throwing whole sets of polygons into the render system to have those things be rejected because they're off the frame buffer, they're well outside of the camera. So it's kind of easy to do that when it doesn't rotate, but when it does rotate, you get these situations here. You can see what the green and the red's showing us. So a grid section is a subsection that's been culled away, and the green ones are where it's gone, okay, this is inside the viewport. And that's actually how it works. It works out a rough estimate of, on the map compared to the viewport, of what region of tiles we need to start looking at, and then we just subdivide from the top level down. So we start with this initial rectangle, slice it in half into quarters, and then we check these subsections. We do the same thing for those. So recursively it gets chopped down block by block. It doesn't use recursion actually, well, it uses a stack, so it's the same thing. So the goal here was to make sure if we can get this thing to work in PV code itself, then clearly that's a pretty good method. I was having a bunch of problems about this determination, of determining the right area given its scale, its rotation. The main situation occurs when we're at like 45 degrees. We would have all of these extra tiles off the frame buffer. There's a point where you get to where it stops recursing. It goes, look, hey, if a block of tiles is, I think it's 4x4, let's not worry about going any further. The cost of recursing for and comparing to a per tile basis is more expensive than actually drawing the block. So that's why we get these kind of areas on the edge there where it's given up. It's gone, look, this is probably small enough not to worry about a few clipped polygons. We could change that really if we really felt like that was necessary. So when I mentioned there was some things I wanted to try, this is one of them. Going back to the old camera days in all of the remakes in PBFX and the OpenGL, the G2D library has a version of this in itself as well, where you can render a map from a camera. It's a classically 2D scene. You still work in the same coordinate system, and it just has depth applied to it, and the camera can rotate around there. So you can get that kind of top-down perspective for free without really having to do any of the math yourself. And that's kind of the aim of this. Of course, if you have a rotating camera and you can't rotate maps, then people would go, well, geez, why is that limitation there? It's ugly to do. It's actually very ugly to do. But I'm pretty happy with the way it's come up this time. This is better than last time. In previous times, I had subdivided the map into chunks and was rejecting chunks, and for some reason that was pretty good, but it tended to these edge cases would fall through. I've been testing this one, writing it for the last couple of days actually. It didn't take long to write. It was more like just making sure the logic works for all of the basic cases. So here we've got a 28,000 polygons in the overall level. I'll just show you that actually. Go back to the code. When we render this thing out, we're just rendering each pixel from the map as a quad. Right, so they're not pixels we're looking at when we see it here. This is not made up of pixels, this is quad renders. And it's a lot of quad renders. That's why I feel comfortable going, all right, this approach is probably good enough to use. And with the recent sort of changes to some of the mapping stuff with how you can read textures from them, it should fit together fairly well. I'm not going to be committed to it, but if it doesn't work, it doesn't work. Then in this version, that's okay. But I think this might be on the more likely side of things than not. But we're going to build this into the mapping library first. Of course, obviously if we can get it to do the reduction, the clipping stuff for us, then how it's rendered down the line makes no difference. Whether it's, with software rendered today, or whether it's, hardware rendered at some other point, well, doesn't matter. Because the same reduction needs to be made. Pretty cool. You can make this higher. It'll choke a bit when we do this, but we'll build bitmap from image. Let's go to that, find that. So we're just loading the texture in. In this case here, we're doing a reduction of it because the logo is huge actually. That's a quarter of its actual size. Let's go to 50%. We'll see how it comes out. It'll run much slower. Now object's bigger because we've got 13,000 polygons. They're all passing through, being clipped, rotated, projected, and none of that stuff's optimal. It's just kind of thrown together for a demo to work out, can we do this? Is it going to actually work? Well, there you go. So in this case here, we've taken 113,000 polygons and reduced it down to 1,500 polygons. Of course, in the real library, we need to do things like maps have tile animation. Some of the tiles don't need to be drawn because they'll be just null. They'll be effectively the mask color tile, so that the sector needs to be scanned. But if there's no polygon there, we don't need to do anything. We just skip on to the next one. So that's good. I can't think of a cheap way of like pre-computing that, but there probably is a way. But it would probably get in the road of people doing stuff. Actual use cases. So that's a map. It's 113,000 polygons, quad polygons drawn. That's a pretty big matzo ball for it to swallow. This hovering thing here too is, so I've added some more Vector 2D stuff to the library so we can sort of do these kind of things, like underneath the shape library. You may have noticed, but underneath the shape library internally, there's a whole bunch of these kind of simple, repetitive things that it actually uses to build up the different types of collision, for example. And so that the vector library has kind of split that stuff out into its own segments, so you can kind of access the low-level things if you need to. That's what I've been doing here. There's a point in quad. There should be a point in triangle as well, just for completeness, really. So the quad can rotate, and that's how I'm doing the point over the rectangle here. I'm just using the internal rotation. It's using a rotate call for every single vertex it calls. So clearly even that could be much faster than what we're doing here, but it's a proof of concept. All right, dudes, that'll do us. That shows what we're up to and how far we've got with this in the last couple of days. I hate to say it, but I'm pretty happy with that. Oh, this is alpha blended too, by the way. Yeah, and so you can, because the outlines are drawn first and the texture is drawn over the top of it with an alpha 50 blend. Insane. We'll try one more thing. Sorry, go back to where we were. It's 50%. Let's try it. Let's try the whole image. So every pixel is becoming a tile in our virtual map. I'll be surprised if this works. Yeah, we're way down the tree now. So we're talking about a potential of 450,000 odd polygons, and we're looking at 165,000 polygons. That's a lot of work. As we zoom in, of course, the reduction will help us out. We're down to 4,000 polygons. That's pretty good. That's much more how you would imagine it from a real world case, and you would never have levels. I wouldn't have thought so anyway. That were one big level that is, whatever this is, I don't know. I think it's probably 2,000 pixels wide or something. Maybe less than that, I guess. All right, that's it for me. That's where we're up to, and we'll see how we go implementing it. If we can't find any more bugs, I think we're about there. I think this much better demonstrates here the subdivision. You might wonder why it doesn't merge some of these sections, because they're actually in neighbouring sections. And it doesn't really matter. Like when we pass it to the renderer, we're just passing it an area of the map, this quad here, and going, hey, draw me this subsection here. Whereas all this other stuff on the outside, all the stuff out here is getting rejected straight away. Because we know we don't need to draw that, no. It's brute force now, isn't it? We're really pushing our friendship there. But that's okay. It's not meant to be fast in through the runtime. Let's go. Alright, thanks for listening and I'll see you next time. Bye.